All right, welcome to Data Within Reach, and welcome to another Rapid R 3-minute tutorial. Well, about 3 minutes. Sometimes they go a little longer. Today, we're going to pick up where we left off last time. In our last tutorial, we did basic matrix algebra using vectors, and this time we're going to do basic matrix algebra using, can you guess it, matrices. You know, the way it was intended. We're going to go over transposing a matrix, adding and subtracting two matrices, multiplying a matrix by a scalar, and then also taking the cross product of two matrices. We've only got about 3 minutes, give or take, so let's get started. In order to do basic matrix algebra, the first thing we've got to do is create a matrix. So the command to create a matrix is matrix. Pretty well named. And again, we use the arrow assignment operator, the matrix command. We pass a vector into the first parameter of the matrix, and then set number of rows in the next parameter in the matrix. And here you can see we have a matrix with 2 rows and 3 columns. So let's have a little fun and run the transpose command that we learned last week is the T keyword into that matrix. And print out the results. Now you can see we have a matrix with 2 columns and 3 rows. So we've got a matrix M. Let's create another matrix N, and let's go ahead and do some addition and subtraction on those matrices. In order to do these basic add and subtract operations on matrices, they need to have the same dimensions. That is to say, you need to have a 2x3 matrix being added to a 2x3 matrix. You can't mix the dimensions for adding and subtracting. So let's run this here and print out the results. Would you like to see what happens if we try to do it with different dimensions? What do you think happens when we try to add these two? Error. So you see, when you try to add two matrices that don't have the same dimensions, in that case we just tried to add a 2x3 with a 3x2, it threw an error. So it's really true. You have to have matched dimensions. Now let's try to do some subtraction. And there you have it. There is m minus n, and that creates a matrix that subtracts the individual elements with the individual elements of the matrix that it's being subtracted from. Scalar multiplication, that's very straightforward in matrices. So here we'll define a scalar that happens to be the number 2, and we will multiply that scalar by the matrix that we defined previously, M. Print the results, and sure enough, it's the M matrix, but each individual element has been multiplied by 2. Next up, let's try matrix multiplication, which is also known as the cross product. Now, with matrix multiplication, the dimensions of the matrices need to be a transpose of each other. Let me just give an example to help explain that. If you have a 3x2 matrix and you multiply that by a 2x3 matrix, you'll end up with a 3x3 matrix. If you have a 2x3 matrix and you multiply it by a 3x2 matrix, you'll end up with a 2x2 matrix because it takes the outside dimensions and uses that to create the new dimensions of the resulting matrix because you're multiplying across and down when you multiply two matrices together. Let's actually just show it. Here we're multiplying the transpose of the M matrix by the N matrix that we defined previously and printing the result here. And you see, because we're multiplying a 3x2 by a 2x3, we end up with a 3x3 matrix. It turns out that R has a built-in function that can perform matrix multiplication for you without the need of running a transpose on one of your matrices. It's called crossprod. And let's check it out. We'll run the cross product of M and N, which gives you the matrix multiplication of a transpose of M with N. And let's make sure that this gives us the same results. Looks like it does. So cross prod is another way of doing a matrix multiplication using R. So I might point out that technically in mathematics, there is no technical such thing as a cross product. Even though R has this function defined and calls it cross product, the technical mathematic name of what we're doing is matrix multiplication. I just want to throw that in there, so I don't want anybody to say the wrong thing in front of a smart math friend and not look like you know what you're talking about. So generally try to refer to this as matrix multiplication. I think this tutorial ended up being a bit more than 3 minutes, but hey, that's okay every now and then. Thanks very much, and if you like tutorials about R programming, or for that matter, if you like other videos related to artificial intelligence, particularly generative AI, please hit the subscribe button and check us out. Thanks so much, and we'll see you in the next one. Bye-bye.